activity tomorrow. So the table gives us information about the women's Olympic 100-meter run and the winning times of that 100-meter run. And then it has the year with the 1900s. So 28 really means 1928. We're going to use 28 though in the problem. We're not going to use 1928. And then it has 32, 36. It jumps to 48. Does anybody know why? It stops in 1936 and jumps to 1948. Gavin, why is that? Yeah, World War II. And we didn't have the Olympics during those years of World War II. So that's why it skips over. So if you're looking at that data, it really does skip over those times. Also, this is the Women's Olympics. And there isn't any data before 1928. That was the first year the Women's Olympics started. That was the first year women were allowed to compete in the Olympics. So this is like true data winning times. That's not something that I just made up. So it's information that we kind of find. Lovely Google finds a whole bunch of things for you. So see if you can enter the data in the calculator. You're allowed to use 28, 32, 36. So you're allowed to use those numbers as the years since 1900. So it says, what is the equation of least squares? That's the same thing as saying the best fit line. You're going to see a couple of different words for that. It could just say find the linear regression equation, or your best fitting line, or the line of least squares. So they all mean the same thing. So we're not technically graphing this one, but we're trying to come up with that equation. Are you good with that? Yes. Do you have the R value too in the program? Yeah. Okay. Does anybody have an equation yet? Nick, what do you have for an equation?
Y equals negative 0.02 x plus negative 0.02 x plus 12.
Negative 0.02x plus
12.7.
12.7. Any questions with getting that? Can I help anybody trying to get that? So the correlation coefficient is R. If you don't have that, remember you need to hit the second and the 0 to get that catalog. You're going down to diagnostic on. Jack, did you get an R value?
Yeah.
What'd you get for R?
0.86.
Why is it negative, Jack? Just by looking at the table, like why would it be negative?
Because the times go down.
Yeah, the times are going down. People are getting faster as time is increasing. So because those times are decreasing, our line is going down. Is this data linear or nonlinear? Does it form a perfectly straight line? No, not quite. It's fairly close to being linear, but it's not perfectly linear. It's only going to be perfectly linear if that slope is 1 and if the R value is 1. So this is still nonlinear, but it's fairly close to forming a straight line. The closer that number is to 1. So what is the slope of the line? What does it mean? Well, we know the slope is that m value. But what does it mean? And this is like that part where you're interpreting. So Josh, what does it mean?
Each year the time goes down 0.02.
Yeah. what, it is still, that's a good question, it is still each year. So even though you're plugging in those 4 years, when you calculate the slope, it would still be negative 0.02 over 1, but very good question. So each year the time decreases, it goes down by negative 0.02, and then don't forget that's in seconds. So it's going down 2/100ths of a second, which doesn't seem like a lot, but that's every year. So then every 4 years, once we hit the Olympics, it would have gone down 8/100ths of a second. So we have then the y-intercept of our equation. Veronica, what do you have for the y-intercept?
12.7.
Yeah, 12.7. I'm going to write that as an ordered pair. Do you know what that means?
The first year, it took a person 12.7 seconds.
And what year would that first year be?
1920.
1928. So in 1928, you could say the average time, because that it really is an average fitting our lines together. It wasn't the exact time. And again, that's in seconds. Remember, it's not going to correlate exactly with the number for 1928. Because this is a line that fits the data best.
Why wouldn't it be for the year 1900?
Because, well, I guess that would be true. Yeah, 0 would be 1900. Thanks, Gavin. So in the year 1900, because 28 is the year 1928, so 0 would be our year 1900. All right, so then F is the x-intercept. And Michael, anytime you find an x-intercept, you do what? Make the y 0. So taking our equation, and setting it equal to 0. Did you get an x-intercept, Michael? What'd you get?
10.94.
So x-intercept 10.94 when the y value is 0. And what year would that mean then? So if we started the data at 1900 represented 0, what year would 10.94 represent? Anybody help trying to write this?
When
Me
the
too.
time, when the winning time average was 0.
So he said the winning time was 0. I guess put seconds with that. What year was the winning time 0 seconds?
X-intercept is 635.
The x-intercept was what?
635.
635.
Yeah.
Okay. Exactly 635? 0.5?
No.
Just 635. Trusting you guys too much. Okay, so Michael, if we started in 1900 and x is 635, what year are you in? Peter wants to help you out. 2,535. So if you take the current initial year, I should say not the current year, but the initial year that we're starting with is 1900. We're going 635 years into the present time, or past the present time, into the future time. So So when you add those together, that gives us the year 2,535. I mean, it could happen, right? Maybe? Josh, do you think it could happen? Yeah, sure, right? That might happen. That's somebody's gonna run 100 meters in 0 seconds. That's what that is really saying. So maybe, I mean, who knows what's gonna happen in 2,535. Letter G says estimate the winning time in 1988. So 1988 would be the 88th year from 1900. So estimate what the winning time would be in 1988. So what would the winning time be in 1988? See, 10.94 seconds. So the American Florence Griffith Jr. won the gold medal with a time of 10.54 seconds. It says make a conjecture about this piece of data based off your estimation. So she was our gold medalist in 1988. I think she was actually the first American female gold medalist in 1988, and her time was 10.54. So you would say that she was, faster than the predicted number, whatever you want to use for there. Her time was better. So I have a second worksheet, again, 2 problems. One's talking about broccoli, and then the other one's talking about life expectancy. When you're looking at the life expectancy, it jumps by 10 years. So make sure that you're correlating your numbers. It's starting at 1920, going to 1930. So your numbers should correlate with the fact that it's jumping for 10 years. And then again, tomorrow we'll look at an activity trying to correlate a couple other things using some classmates' data. And we'll summarize the linear regression information tomorrow.